Alright, here we have a common miscommunication between a drafter and a carpenter, where the drafter has technically put in enough information to produce the product, but the carpenter, with the limited tools he has, does not have the ability to use this information to accurately make the product. So what do I mean by this? So this is a 2x4. The drafter has provided us with an angle of 12 degrees. Let's zoom in here. But if the carpenter only has a measuring tape, a pencil, and a handsaw, he doesn't have a protractor, so we can't make a line for 12 degrees. What the carpenter would do is take his measuring tape at this corner and pull it this way and figure out whatever length this needs to be and mark it up. Okay, so we need to figure out what this length needs to be so the carpenter can, again, pull his measuring tape back and mark it at this particular spot. To figure this out, the first thing we need to do is figure out what information we have and plug it into the law of sines, which I will show you in a bit. So what we're going to do is just hand sketch a larger version of this diagram here and put information in. So the triangle in question looks something like this. Let's expand this up. And I'm just going to use dashed lines to illustrate the 2x4. The drafter has given us 12 degrees. Okay, this is a 2x4, so this is going to be 90 degrees. A 2x4 is nominally 2x4, but the width of the plank is actually 1.5 inches. And we need to figure out A. Alright, we might as well just figure out what this information is. This particular angle here, we're going to call that theta. So a triangle is 180 degrees. And we already have two angles. We have the 12 degree and the right angle of 90 degrees. So we're going to subtract 90 and then subtract 12. That's going to give us with 78, I believe. And that ends up being what theta actually is. So with these two pieces of information, theta and 1.5, we can have the first section of the law of sines. So I'm going to do this right over here. So we have 78 degrees. The sine of 78 degrees over 1.5 over, we're going to match the length here, over A, and the sine of 12. So just a quick recap of what the law of sine is. It is basically saying that this pattern can be translated across all other sides and angles, but you need either the angle or the length in order to fulfill this part of this section. So what we're doing here is 78, so we have theta here and 1.5. These are the matching information, and we have sine 12 and A. Those are matching. So we want to find A. Sine of 78 degrees over 1.5 equals sine of 12 degrees over A. At this point, all we need to do is pull out a calculator and do some basic algebra. Let's clear everything out here. Okay, so we're going to find the sine of 78 degrees first. That is 0.978. Okay, over 1.5. And then we're going to find the sine of 12 over A. 12. Oh, I don't want to do that second function. Sine of 12 is 0.208. Okay, we're going to simplify this left section a bit more. So 0.978 clear everything out here. 0.978 divided by 1.5 equals 0.652. I'm going to move that to my other screen. 0.652. And that equals 0.208 over A. So I want to isolate A and get rid of this fraction at the same time. To do that, I'm going to multiply both sides by A. A over 1 and A is the same thing. Alright. And it basically looks like this. These A's cross out. We're left with A times 0.652 equals 0.208. Okay, we're going to divide both sides by 0.652. These are my parentheses, how handsome they are. 0.208. Alright. So here I'm isolating A. In this step of the process, I just got rid of the fraction. 0.652. Here we go. Alright, these cross out. We're left with A on the left side, and on the right side we have 0.208 over 0.652. Pull out that calculator again. 0.208 divided by 0.652, and we're left with 0.319. Okay. So now we know what that decimal number is for that length that the carpenter has to pull back. So 0.319. Now, the carpenter isn't going to have decimals on his measuring tape. He's going to have fractions. So from here we try to find the closest fraction that is available on the measuring tape, and that would be in 1/16 of an inch. The closest increment in 1/16 is 5/16, which is 0.3125. Alright, so we could just say at this point that this angle here needs to be 5/16. So now the carpenter can pull his measuring tape back from this corner to this mark right here, 5/16, draw that mark, and then take his handsaw and begin cutting from that corner to 5/16 in. Hope this has been helpful for you. Have a great day.